Hello, everyone. Welcome to course P25, Shielding Gas Investigation Overview. This is a very brief course going over the issues surrounding the possibility of shielding gas issues in the cell. Most commonly, of course, is porosity. Now, most people see porosity and immediately think to themselves, hey, I've got a shielding gas problem. Most often, honestly, through investigations, it is something else, some level of contamination or something mechanical that might be messing around with the shielding gas flow. Sometimes even broken air lines blowing in a particular place. So I thought I'd go over a little bit of a process that I use. I go through when I go into a plant and I'm doing some type of a shielding gas investigation. So this is my little checklist. This is where I start. I note the essential weld parameters. So I want to see how it's running right now, if anything seems out of place. And I'm trying to figure out if there's a pattern. Is it in a particular place you're getting this location you're getting this problem? Is it a particular time you're getting this problem? Are more than one robots running when this happens? Is it when there's more than too many gas problems or gas regular flows happening at one time that might be causing these issues? But this is where I'm trying to find out patterns. I'm immediately starting off in that direction. Now, most of the time we're dealing with bulk or whatever, but let's remember one thing when we're talking about our regular gas metal process where we use argon and CO2. Here's an important point for you. If it was all argon or if it was all CO2, either one, you still would not get porosity. It wouldn't be the greatest weld, and there's lots of companies that run straight CO2 all the time. Now it does like I said, it looks a little bit weird when you have there's funny waves in the weld when it's all argon. But keep in mind that the imbalance of these gases will not cause porosity. So if your mix is off, there's a bunch of other problems. But if the mix is off, it's not causing porosity. If you got a robotic application, these are the ones I'm always interested in, because sometimes you've got to trace your pipes back and find out if you have a loop system. The linear method of applying gas to any a shielding gas delivery system is probably the worst, where you start off here and you finish up at one end. You should always loop your system. So if I'm going anywhere, if I'm setting up a shielding gas system, and I've designed shielding gas systems, I usually run two pipes. I usually run right to the end, and then I use another one to take me to the end, and that's where my drops are. So I have a balance. I have a system that's connected. If you've got a building and you can go around the building, go right around the outside and then tie it back in to make sure that it stays balanced. Here's the key feature to the whole thing. It's compensating. So if you get a bulk of gas that removes, everybody comes back from break and everybody pushes that button at the same time, there's a bulk of gas that's being removed at the same time, and it's compensating. So it helps out when you have a loop system. Evaluate for leaks for gas, depletion, kinks, so forth. I have seen a robot go into a position and stop the gas flow. There was all kinds of little tools and meters we could put in to check for all these things. Feel free to get in contact with me. I have everything we need to check your system to make sure it's okay. But we got to make sure that's not happening. And keep in mind that a leak is not porosity. A leak is a lack of gas, which could lead to porosity. But air cannot get back in, cannot defeat the pressures that are on the other side of your shielding gas system. So don't believe that when some people say, well, there's a leak of gas there, so probably air is getting in. No, we only live under 1 bar in this world, and that's about 14.7 pounds per square inch. There's pressure here, but it's not enough to overcome the 30 or 50 pound pressure that you have inside your piping system for your shielding gas. Now this one could get very complicated, this situation, if you believe it. We've got other things to think about. We have our liquid systems, so we have to think about evaporation and so forth. So if anybody had any questions and they want to talk about shielding gas systems, what's the right shielding gas system for you. Please let me know. And here's my number. You can feel free to contact me by email or text or call. Thank you very much. Have a great day, and let us know if you need anything else.